Section 510 is solving exponential equations with different bases. We're actually not going to check the solution this time. We are basically just going to focus on solving exponential equations that have different bases. And we're going to do that by using the inverse function of exponentials, which is logarithmic properties. So we are going to practice some of these properties that we had in section 510 or 5.9. So we're going to expand these. So when we expand, it means that each base is going to get its own log. So for example, we have this base and we have this base that is each going to get its own log. So we're going to rewrite this as log of x, and we have log of y cubed. And when we multiply the two bases, what do we do with their logs? We add them. So this is going to become, this multiplication is going to become addition. So this is plus. And then the only other thing that we have to remember to do is this exponent is going to become the coefficient in front of this log. So this would be log of x plus log of y, and we need the 3 in front, so 3 times the log of y. Okay, so each base, the x and the y, each got their own log, and the exponent on the y, once you put the log on there, comes out to the front. So it becomes the coefficient. So this part right here, where the exponent comes down in front, is the power rule. And the one where we add these two, that is the product rule. So those are the two rules that we're using for this one. So in the second one, again, we have one log, but we want to expand it, so each base is going to get its own log. So I have an x that's going to get its own log, and I have a y that's going to get its own log. So we're going to write log, whoops, log of x squared. Now division.
Excuse the interruption, but teachers, please release the girls' track team at this time. At this time, please release the girls' track team. Thank you.
So division is going to turn into subtraction. So this is going to be minus. And then we have log of y. Now the only other thing that we have to do is we have this exponent up here that needs to become the coefficient out front. So we have 2 times the log of x minus log of y. Okay, so again, because of this exponent, right, this is the product, or sorry, the power rule. And because of the division turning into subtraction, that is the quotient rule. All right, the last one, we have log of x minus 4 squared. So we are going to, we only have one base in this one. Okay, so the base that we have is this one right here. Oops. We have this base. So the only thing that we're really going to do with this one is take this exponent and move it out to the front. So this becomes 2, and then log of x minus 4. And the only rule that we used on this one is the power rule. So for the next set, we're condensing each expression. So now instead of expanding and making each base get its own logarithm, we're gonna take each base take each logarithm, condense it into one, and then with those other bases, we're gonna turn that into either multiply or divide. So with this one, we have that 3 out front, and so anytime that you have the coefficient, this is going to have to become the exponent on your base. So this one would turn into log 2y, and then we would cube that. Okay, on this one, we have addition between the two, which means that we're going to be using the product rule. So these two logs will combine into one. And then we have the x and the x minus 3. And since their logs are being added and we're condensing it, those x's are going to multiply. So we have x times x minus 3. And if you wanted to, you could write it as x squared minus 3x. All right, so same thing here. We have this coefficient of 3 out front, so that is our power rule, where we're going to take that coefficient and it's going to become the exponent. So we're going to have x cubed. And then we have the minus x, which just means divided by x. And each one of these two logs is going to turn into 1. It's going to condense down into 1 log. So you can leave it like this, or you could write it as log of x squared. So the next thing we're going to talk about is what happens when we have equations with same bases. We've already solved those, but what happens if I can't change the base and solve when those two bases are different? So in this one, the problem that we started off with initially was 2 to the power of x minus 5 is equal to 32. And we said, okay, well wait, I can rewrite this base as a power of 2. And I know that 2 to the 5th is the same thing as 32. So now we have two bases that match. And so because those two bases match, I just need to figure out what x is going to make those two exponents equal to each other. So we would get x is equal to 10. And now we have 2 to the 10 minus 5 is equal to 2 to the power of 5. Those two are equal to each other. But what happens when I can't rewrite them as powers of the same base? I can't rewrite 3 as 2 to the power of something. It's just not possible. So here's what we're going to do. We know that solving exponential equations with different bases, we need to use the inverse operation. So the inverse of exponential functions are logarithms. So if I want to solve for x here, and I can't rewrite 7 and 20 as powers of the same base. So I would have to, I'm going to rewrite this, and I'm going to leave a little bit of space after each one of these. So I've got 7 to the power of 3x is equal to 20. And you'll see why I'm leaving these spaces here in just a second. So in order to undo exponential, we need to do a log. And whatever we do to one side, we have to do to the other. So log of 20. Log of 20 on this side, log of 7 to the power of 3x. Now, we also know, we just got done expanding and condensing, that when we have this exponent up here, this is actually going to be the same thing as 3x log of 7 out front as if I were to have this exponent up here. So we're going to take 3x, and then we have log of 7 is equal to log of 20. Now, think about what we're trying to do. When we are solving an equation, the whole goal is to get x by itself, right? So the way to get x by itself is to undo whatever is happening between the 3 and the x and the log of 7. So all we're going to do is divide by 3, because that's going to cancel these two out, and we're going to divide by log 7. That's gonna cancel these two out, and we're just gonna be left with the x. So we would do the same thing on the other side. We're gonna divide this side by 3 log of 7. Cancel, cancel, so now we have x is equal to log of 20 over 3 times the log of 7. So we have the next one. Pause and write it down if you need to. You should be working along with me. Anytime that you see an E, okay, remember that's one of our special bases. And so to undo E, and I'm going to rewrite this again, but I'm going to leave some spaces. So we have E to the power of 4x is equal to 15. So again, I want to undo this E. I want to get this exponent out to the front. So we're going to do ln of E. And whatever I do to one side, I have to do to the other. So this is ln also. And again, this exponent up here is going to come down into the front. So we have 4 ln of E is equal to ln of 15. Now, the really special thing about this is that anytime that you have an ln and an E next to each other, it's really just the same thing as 1. So you're taking 4 times 1, which is just 4. Sorry, there should be an x after that 4 here. Okay, so really what we're left with is 4x is equal to ln of 15. And all we want to do is solve for x. We want to get that by itself. So we're going to divide by 4 on both sides. Those two cancel. And so x is equal to ln of 15 divided by 4. Okay, I'm going to do one more with you. Actually, I'm going to do 2 more with you. I'm going to do this one, and then we'll do the last one. So on this one, again, I'm going to rewrite this one with a little bit of space. I have e to the power of x plus 2 is equal to, and then I'm going to leave a space here for 10. So again, I have this e. So anytime that we have e, we're going to use ln. And our exponent is going to come down. So we have x plus 2 times the ln of e. And remember, ln of e is the same thing as 1. So really, on this side, we just have ln of e, or sorry, x plus 2. And we don't need these parentheses. And on the other side, we just have ln of 10. So how do we get rid of this plus 2? We would subtract 2. Now, I can't subtract the 2 from the 10 because this is a number, right? I don't know what that number is, so I'm just going to subtract it afterwards. So this would be x is equal to ln of 10 minus 2. And I'm going to put that ln of 10 in parentheses to show that that is one number, and I have to do that part first before I can subtract the 2. So x would be equal to ln of 10 minus 2. All right, last one that we're going to do today, and I'm going to show you guys just a quick example to kind of help you with this one. So if I put 5 minus 3x, not 5 minus 3 to the power of x, but just 3x equals negative 40, we know that the first step that we would take for this equation over here would be to subtract 5 from both sides. Because what we're trying to do is we're trying to isolate this part right here. And so that's the same thing that we're trying to do over here. We're trying to isolate this part that has the x in it. So the first thing we need to do over here is subtract 5 from both sides. So we get negative 3 to the power of x is equal to negative 45. And then we can't take the log of a negative number And so what we need to do is we need to get rid of these negative signs. So what we're gonna do first is we're gonna divide by -1. And so we get 3 to the power of x is equal to 45. And I'm leaving a little bit of space in there because, again, we need to make sure that we have space for that log. So we're taking the log of 3 to the power of x and we're taking the log of 45. And again, this exponent is going to need to come out and become the coefficient. So we're going to have x log of 3 is equal to log of 45. And the way that we get rid of this log of 3 is just by dividing, because this is x times the log of 3. So to get x by itself, we need to divide by log of 3. And so we get x is equal to log of 45 divided by log of 3.